This is John Black, super chemist. Now, for the the benzyl trichloride, that one's an easy one because you just put in 3 moles, a little bit over 3 moles of chlorine and 1 mole of toluene, and you just let it react. Now, the thing about this reaction is because you're making free radicals, they are really extra reactive. As soon as you make them, they want to do something. They're going to attack anything. And so when you do this reaction, I showed you the apparatus, how you'd have the HCl gas that you're making would be coming out and going into a suckback trap and then a scrubber of sodium hydroxide. Now, if you take off the scrubber, the only thing you should smell is hydrochloric acid. If you smell any chlorine, that means the reaction's over. You should not smell any chlorine whatsoever, none. Okay? If you are, then you need a better UV source. Okay? Your UV source isn't strong enough to make, turn it all into free radicals as it's coming out the tube. Or else you're not directing the light right where it comes out of the tube. So keep that in mind. If you smell any chlorine, the reaction is either over or you're doing something wrong. So you just pump in your chlorine for this, and wham, bam, there you go. It's all going to transform into, you don't have to worry about these, because if you put enough chlorine in there, you're going to turn it all into benzyl trichloride. Okay? What you can do with that, I don't know, other than hydrolyze it and make benzoic acid. The OH would come in, do an SN reaction, and then you'd have an OH there and 2 chloro groups. Then another OH comes in, does an SN, takes out another chloro group. Now you have 1 chloro group and 2 alcohols. And anytime 2 alcohols are Gemini, or geminal to each other on the same carbon, they will automatically turn into a carbonyl group. So you'd have a carbonyl with a chloride. So that's an acyl chloride, right? But acyl chlorides are so reactive that while you're hydrolyzing, all the stuff that's hydrolyzed will hydrolyze it down to benzoic acid. And since you're using a sodium salt to do that, it would turn into sodium benzoate. So that is the easy, the easy part. If you wanted to make this and hydrolyze it into benzoic acid, because you won't have these impurities. You just chlorinate it until you get everything chlorinated. You know what I mean? So the only thing left on these videos right now is the hydrolysis. Okay, I only went into this generic little thing here. So the next thing we're going to talk about and get more in depth in is which temperatures are best to reflux it at, which salts are best to hydrolyze it with, and how you actually do it. What you do to hydrolyze these and get these chloro groups off and put on either a hydroxyl group, a carbonyl, or a carboxyl group. I wanted to reiterate about the benzyl trichloride. I didn't look up, anything about how to make it. I would just guess, if you got 1 mole of toluene, 3 moles of chlorine, and when it's done, it's done. That's after the 3 moles. Some of it probably won't react at the very end when there's only a couple molecules of benzyl dichloride, and everything else is trichloride. It's going to be tough for the chlorine to meet up with that 1 or 2 molecules. So you know what I mean? You're not going to get probably a full whatever, but should get close. But anyways, I wanted to now on. These are when I say benzyl chloride derivative or derivative, I'm talking about these 3 things. We're going into how to hydrolyze them. This gets hydrolyzed to benzyl alcohol, benzaldehyde, and benzoic acid. The reason why an OH comes in and does an SN, so it takes the chlorine off and puts an OH. This one, it takes the two chlorines and puts two OHs on. Anytime you have two hydroxyl groups that are geminal like that on the same carbon, they automatically turn into a carbonyl, so that would be benzaldehyde. Now imagine this, these two chlorines turn into a carbonyl like benzaldehyde, and this turns into an OH. That'd be a carboxylic group, just so that'd be benzoic acid. Now I'm just going to go into some facts about hydrolysis, and then I'll tell you what I would do or what I plan to do. The derivative is, and this is just, these are generic things. I'm talking about all three of these in general. The derivative, meaning one of these, is heated until free of all chloro groups. So you're just basically heating it up. A cloudy precip will form on contact with compounds containing a side chain chloro group if alcoholic silver nitrate is used. So if you want to test to see, you're doing your hydrolysis, you're refluxing it, you're heating it, now you think you're done. If you wanted to test, you could get a little sample out, mix it with some alcoholic silver nitrate, and if a precip forms, that means there's chloro groups. If no precip, then your hydrolysis is complete. Okay? Now, what's the preferred hydrolyzing agent? Hydroxides, carbonates, and bicarbonates of group 1 and group 2 metals. That's the preferred agent to use, okay? What are the three best ones? Right here. The third best one is sodium hydroxide. That's just drain cleaner. Baking soda, sodium bicarbonate, is the second best. And the number one overall one is sodium carbonate, which you can just make from baking soda by putting it in the oven above the boiling point of water, and the water will boil off and you end up with sodium carbonate. Now, why are these two better than this one? Because they cut down on the formation of dibenzyl ether, and that's one of your contaminants. You want to keep that down. What's the concentration of your hydrolyzing agent? Well, it depends on the agent you used, first of all. But in general, you can say 2 to 20% by weight. Preferred would be 5 to 15. And of course, the best would be 10%. And anytime you see something saying dilute, usually 9 out of 10 times, not 10 out of 10, 9 out of 10 times, dilute means 10%. 10 to 20%, but usually 10% is what dilute means. That would be the best. But again, it depends on your agent you use, but I'd go with 10%. What's the ratio of aqueous phase and organic phase? Again, it may vary, but in general, a range to get into would be 1 to 15, to 9 to 15, or 3 to 5. And preferably is about 1 to 5. And I put here 3 to 15, just so you can see. This is one in between 1 and 15 and 9 and 15, and the best is 3 to 15. I'm not sure about all that, but let's move on. Okay, now the agent should be at least stoichiometric. So if you have, you have a mole of chlorine, you need to get off of the toluene, then you'd need a mole of hydrolyzing agent. Keep in mind, if you're doing benzyl, the dichloride derivative, then you need twice as much hydrolyzing agent. Just like if you're doing the trichloro, the benzyl trichloride, you'll need 3 moles of hydrolyzing agent to be stoichiometric. It usually is double. Usually you put double the amount that you need stoichiometrically, okay? But it's preferred to be in excess between 5 and 20% of stoichiometry. So if you have a mole of chlorine you need to get off, I would suggest a mole and 10% of a mole, because that's in between this. A mole and 10% of a mole of hydrolyzing agent. That way you have 10% in excess. What's the temperatures of hydrolysis? Range it anywhere from 10 to 300 degrees Celsius will be good. But what's preferred? 100 to 180 C. And what is the very, very best? Between 120 and 150 C. Now, 180 C, it only takes a couple minutes for this reaction to happen. But guaranteed you're going to have a lot of dibenzyl ether as an impurity, and I'll get into that later. But the best temperature would be 130 C. What's the best pressure? Well, the pressure should be between 1 and 60 atmospheres. Best pressure would be 1 to 20 atmospheres. Now I'm going to do mine at atmospheric pressure, so that's 1 atmosphere, so that's within the best. So the pressure is 1 atmosphere. Another thing is dibenzyl ether is formed in the final product by about 0.5 to 30% by weight. So when you get done, 30%, anywhere from 0.5% to 30% of your stuff has been transformed into dibenzyl ether. Now, how can you cut down on this formation of dibenzyl ether? Well, there's 4 things you can do that would help. One is use the best hydrolyzing agent, sodium carbonate. 2, the lowest amount of hydrolyzing agent you can get away with. You know what I mean? That's why I said 1.1 or 10% in excess of the stoichiometric amount. Use an inert solvent like toluene, okay? And I'll get into how much toluene you should use in that. Low reflux temperatures. The higher you get up, that's why, you know, at 180 C, sure, you'll be done with the reaction in a couple minutes. But if 30% of it is dibenzyl ether, you know, it might not be that great of an idea to do it that hot. Let's see what else. To get rid of all the chlorinated toluene, the hydrolysis is allowed to complete, which takes about 20 to 30 hours or more. Okay, remember how I said you can put the alcoholic silver nitrate in the test, you know, get a little couple drops out of your reaction, put it in a test tube with some alcoholic silver nitrate. If it doesn't get any precip, no cloudiness, then you're done. If there's cloudiness, that means there's still some more chlorinated products in there. Now, am I going to reflux 20 to 30 hours? That's ridiculous. That's just way out of my, no. And the last thing on this board, dibenzyl ether will decompose into benzaldehyde and toluene at high temperatures. So if you did mess up and you made a lot of this dibenzyl ether, I don't know what temperature or whatever, but maybe you can reflux it at a very high temperature, and then as it decomposes into benzaldehyde and toluene, it distills out. Maybe, I don't know. But this, you know as much as me by reading that statement, okay? But you might be able to get some of your product back if you did that. I don't know. So the amount of inert solvent, toluene, ratio with your alpha chlorinated toluene should be 0.5 to 1 to 1, meaning somewhere the inert solvent somewhere in between there to a ratio of 1 by weight. This is even better, say 0.8 to 1.2 for the solvent, ratio to 1 to the chlorinated toluene, and the best would be a 1-to-1 ratio. Okay, now if you remember, if I was making the BENZAL or benzyl chloride, right, with 1 chloride, we ended up with 50% toluene left there and 50% or 45% or something like that of the toluene, right? Because we only chlorinated enough, you know, to chlorinate that much. We don't want to do any more than that because we'd have a lot of impurities, right? Anyways, y'all have a great day, and always remember, science is great.